We've got a great set of speakers for you today. So I'd like to introduce Yang Gu. Where's Yang? Please come up, and we'll get off the stage. So Yang leads the Intel's Advanced Web Technology Group in Shanghai, China. And so please give him your warmest welcome. Okay, here we go.
Thanks, Ken. Hi, everyone. Good morning. This is Yang Gu from Intel Advanced Web Technology team. Last year, I did an update here. I talked about Intel's updates on the web graphics. So here comes some updates for this year. Before diving into the details, let me first introduce my team a bit. We have been focusing on web graphics for about 8 years, and we contribute a lot to the WebGL 2 together with Google. And our current focus is on the Web GPU and WebGL 2 compute. So currently, we are the Intel representatives of the Khronos WebGL working group and W3C Web GPU community group. We have been acting as a quality gatekeeper on Intel platforms on both the conformance side and the performance side. On conformance side, in the last year, we worked very closely with our driver team, that is Windows driver team and Mesa driver team, to integrate WebGL CTS into their continuous integration system. So with this effort, all the changes to Intel's graphics driver that may break the WebGL conformance will be caught timely, even before every check-in. So we also want to thank a great effort, great support from the Google Chrome team for their great test framework on this. And on the performance side, we have been doing the monthly performance test, always against the latest hardware, latest OSs, latest driver, and latest browsers. WebGL 2 compute is a major contribution from my team. This is basically to bring the OpenGL ES 3.1, mostly the compute shader features, to the web. We already have a draft specification published at the Khronos website, and we already have the code available in Chrome on both Windows and Linux backends. And due to the great contributions from the community, we already have very great samples here. For example, we are working on the TensorFlow.js WebGL 2 compute shader backend. And thanks to the great work by a Russian physicist named Evgeny, he did all the great job to optimize the matrix multiplication based on the WebGL 2 compute. And we already also have some very great demos related to the compute by the nine-ball syndrome. So as the next step, we will continuously to bring some performance critical features such as subgroup support and the FP16 support to this feature. Another issue, another major effort at our side is about the parallel shadow compare. So I get many of you may get stuck for the slow shadow compare. So to answer these questions, our solution is the parallel shadow compare. So with this feature, we remove the shadow compare from the main thread, and at the same time, you can utilize the multiple CPU threads to compare your shadows. We have some performance data here with 2 CPU shaders, 4 CPU shaders, threads, and 8 CPU threads. We can see very obvious performance boost with this feature. Some major WebGL framework like Babylin.js, 3JS already have this integration. Just try it out today. Another good feature at our side is to support zero-copy video uploads into WebGL texture. We already have a draft spec for that. And our first implementations inside Chrome already showed a very obvious speed up on some contents. We will continue to polish this feature. Last but not least, we always have a question, or we always wonder what's the performance diff between the native and the web. What can we do for the web to optimize some general overheads or bring some new features to the web? Our answer to this is a Project Aquarium. You may know Aquarium before. This is a de facto WebGL benchmark, but we ported to the native, and we already have a various native backends for it, that is OpenGL, D312, Angle, and Dawn. And we just released the project to the public a week ago. During the implementation, we worked very closely with the Angle team and the Dawn team, and got a very generous support from them. And we also have to find many issues from it and some missing features inside these projects. As the next step, we will continue to port it to various other backends like D3D11, Vulkan, and Matter. So that's it. If you have any questions or suggestions, feel free to talk to me or email me. Thank you.
Thanks, Yang. The collaboration with Intel has just been wonderful. We're very grateful for it. They've devoted a lot of engineering time to the WebGL ecosystem and implementations.